Hello, everyone. Welcome back to another episode of our programming in PHI 512 Season 1 with me. Um, so in this episode, we are going to engage a little bit more um, with Lab 2 material. So looking at, for example, the summarize command and the mutate command. So summarize, again, is to create summary of data objects. The mutate command is to modify and create new columns. And we will also look at creating box plots and stratifying box plots. So again, let's look at where our working directory should be and then create a working directory there. So again, I have a PHI 512 folder in my documents, and then I have this lab 2 folder where I have an R script and my data. So the first thing that I'm going to do is I'm going to open up this lab 2 supplement script that I've written and will be providing. So how do we do that? Here we're going to say File, Open File. And again, I'm already there, but it's going to be lab2 supplement script.r. So I open that, and that opens as a script in my upper left. And yeah, let's imagine for a moment that it didn't have this working directory in here. How do we get the right working directory? Well, we find this lab2 folder that I want to engage with. And again, on a Mac, I can right-click and then hold Option um, and click Copy lab2 as path name. Right? And it's important that I'm copying this folder, that I don't try to copy the path name of one of the files in here. And then I would paste this in between the quotes in set working directory. As a reminder, on a Windows machine, rather than forward slashes, you will have backward slashes, and you will have to change those to forward slashes. Also, sometimes on a Windows machine, people have been saying that this sort of control or right clicking and then pressing option and doing this copy doesn't work. In that case, I think there's a properties. When you right click, there's a properties tab that you can click on. Here we have get info. And in that, it will say where this thing is. So again, I'm not totally sure where, well, I can't exactly see precisely where it is here. But again, when you right click and click properties on a Windows machine, you should be able to get that same path. But final reminder, you're going to have backslashes on a Windows machine that you will have to turn into forward slashes. Great, so we've copied that in here. You might want to now save this new script file. I use Command S, so you could also click File down to Save. Mine's already saved. Once you have that new working directory, so that if you close R and reopen it, you will still have the correct working directory in there. Perfect. So the first thing we do is we run this command to set our working directory. It works. The second thing we do is we run this command to read in our data, read in this NHANES data, and we name it DAT, and we see it in the upper right-hand corner of our screen. Perfect. It appears to be working. All right. So the next thing we're going to want to do is create a box plot. And in particular, actually here, we might want to look at two box plots. So the first thing we might do actually is look at just a box plot for age. So again, a box plot expects at least one input. And here the input is a vector containing the numbers we want to create a box plot for. So let's imagine here we just wanted to create a box plot for age. We could run this command and we see this picture in the lower right. One last thing I want to mention before moving forward. Sometimes you'll run this command and you'll get an error. Oh, it's trying to do stuff and it's blowing up. Often it says figure margins too large. And what that means is this window in the bottom right-hand corner is just size too small. If we resize that bigger and then rerun this, then it should work. Awesome. So we can create this box plot. It doesn't have any labels. Otherwise, it looks basically fine, right? This is a box plot of the ages of everyone in the study. Again, the center line is the median, sort of the center of our distribution. It's another way of looking at the data that's kind of like a histogram, but gives the information slightly differently. Now, if we wanted to, say, change the title, we could add in the optional input called main. We would say main equals box plot for age. And if we run this, then this will change. It adds a title. Excellent. One last thing we're going to see is often we don't want to have all of our inputs for a function on the same line because the line can grow very long. So one thing you can do is you can use separate lines. Here you can add a new line command after the comma, right? So between each input, we include a comma, so you can have a new line command. And again, R is sort of smart enough to know that when we run this first line, because our open parenthesis hasn't been closed yet, it will then try to go to the next line for the next input. So again, if we tried to run this, we're not going to get a mistake. It just keeps running and it runs both lines. Great, and it makes our plot. Excellent. So rather than just a box plot for age, it might be we want to look at a box plot for age, but we want to look differently for people with sex identified as male than those with sex identified as female. So how would we do this? In the box plot command, rather than actually just that one vector we're interested in, we can actually have one vector and then a tilde and then another vector with categorical or a factor variable that we want to stratify based on. So here, for example, we could plot box plots for age but stratify on sex. Great, that's sort of our first input. We have a comma, then we want to change the Y label, and maybe we want that to be age. We have a comma, then we want to change the title and maybe call it box plot for age stratified by sex. So if we click the first line and click run, again, R knows that it should run all three lines. In the lower right-hand corner, what do we get? We get this set of two box plots for age stratified by sex, and we see we have those identified as female on the left, those identified as male on the right, and the ages are relatively similar. Excellent. And again, if we wanted to save this so that we could use it later, say put it in a write-up, there are various ways to do it, but we could click export and then save it as an image or PDF and then copy that into a document, or even copy to clipboard and then just paste that in using Microsoft Word. Excellent. So that's how we create a stratified box plot. The next thing that I wanted to talk about is taking a data set and adding a new column. So the way we add a new column to a data set is using the mutate command. And I actually have a complicated mutate command, but let's update our data set with a simpler mutate command. So we would say dat. We would pipe this into mutate, right? So that says, okay, apply mutate to dat. And now the first thing we do is we type in the name that we want for the new column. So I mean, we could call this anything, but I will call this twice.age. This is going to be a very silly column to make, but maybe we want it. And we could say twice age equals 2 times age. So what will happen? This will look in dat at age. It will take that column. It will multiply every entry by 2, and it will make a new column called twice.age with those values. So if I run this, oh, what did I forget to do? I forgot to run library dplyr, tidyverse. So let's take a step back and see what happened. When I tried to run that command, R said error, could not find this pipe thing. And that's because I'd forgotten to load the library that brings the pipe into R and lets me use it. That's the tidyverse library. So I write that in my script. I like to write it at the top because I want to run the script sequentially. And now I need to run this command. And when I send this out, I'll include it with this correct library command. So I run this command, library tidyverse. Great, and it loads that library. And now when I go down and try this again, it should work. Excellent. So now we see it spit this new data set out to the screen. Probably I don't want to do that, so I'm going to save this as Noah's Goofy dataset. Again, I want to hold on to this so I can look at it. So I run that, and now I have a new dataset called Noah's Goofy dataset with 16 variables, right? It has a new one. So we could look at noahs.goofy.dataset age, and if we run this, we get all of these values. We could also look at noahs.goofy.dataset twice.age. And if we run this, what we should see, if we look back, is that all of the values in this are twice as big as their corresponding values. So the last number was 64 for age, and it's 128 for twice age. That's twice as big. And we could go back and make sure that all of those match correctly, but they should. Excellent. So that's not going to be a useful new column, right? That's not really what we care about. Instead, what we might care about is taking this albumin creatine ratio that was written as ACR_MGG, and instead of looking on the original scale, we might want to look on the log scale. So what do? We again use the mutate command. Now with our original dataset dat, we're going to ignore this new Noah's Goofy dataset as we move forward. So we take dat, we pipe it into mutate to create a new variable. We want to call that variable acr.log, and we want to set that variable to be equal to the log of this original ACR value that's in our data set. This is one of the columns in our data set. Log takes in two inputs. One of the inputs is the base of the log. You don't have to pass this in, but you might want to. And the other input is the vector we want to take the logs of. So what will this do? It'll take this vector, it'll take every entry, take the log in base 10, and then it will store that in this variable called acr.log that will then be added to this data set that was originally called dat. And then we want to take the output of that and call that new data set dat.update. So when we run this line, dat is not actually changed. Dat.update is this new version with a new column. And again, we can see dat.update has 16 columns where dat only had 15. And we could look at, for example, dat.update acr.log. And this will tell us what's going on. So these are not the original ratios, these are the log of the ratios. Right? And we see everything looks great. The one thing we have to be worried about is there are a couple of missing values here. And these missing values, these NAs, can get us in a little bit of trouble if we're not careful. So let's look at how they can get us in trouble for a second before moving forward. Let's imagine I wanted the mean value of this vector. So we know to get the mean value, we can type in mean open paren, and then the vector we want to take the mean of. If we run this, it says NA. So when this mean function doesn't like it when there are NAs in our vector, and when we try to take the log, its default is to say, take the mean, its default is to say, I can't take that mean because there are NAs. In order to sort of force it to, we have to add in an optional input called na.rm. So we say na.rm equals true. Na.rm says, do we want to remove the NAs or do we not want to? So if we set this optional input to true, then that means it looks at this first vector. It identifies all of the values that are NA and it just removes them and then takes the mean of the remaining values. So if we were being really careful, we would look into a little bit more, why do we have NA values? Right? This is related to missingness of data, which can be quite important. You can have bias if you just remove missing data and then summarize what's remaining. For now, we're not going to worry about it. It's also only a very small amount of missing data. Excellent. So if we run this command, then we see, okay, once we've removed the NAs, we get a mean value of 0.93. Perfect. We could do the same thing with median. So it turns out median, we know, is a function that takes in a vector, right, and will report that single value median. It doesn't want to do it. Median is another function that has an optional input called na.rm, and we can set it equal to true and then run it, and voila, it works. Not every function will have an optional input called na.rm, but many of them will, and especially the ones that we're going to be engaging with. Great. All right, so we have now transformed this ratio so that we've taken the log of the ratio. The next step is to use the summarize function to get this summary. You have seen that we can sort of do this in two lines. We can create our new data set, and then we can calculate the mean on one line, we could calculate the median on another, and that's fine, but often a cleaner way to do this is using the so-called summarize command. So the way the summarize command works is on the left, it takes a data set that gets piped in, and on the right, the summarize command describes how we want to summarize that data set, right? And in this case, what do we want to do, or what did we do in line 20? We took this log ratio and we calculated the mean and we removed the NAs. And so we're going to do that same thing inside this summarize command. So again, we pipe our data into the summarize command. We want to create sort of a new summary that we are going to call mean.acr.log. And we are going to set this equal to the mean of the variable called acr.log in dat.update. And when we're calculating this mean, we also want to remove NA elements. So again, these two lines should feel very similar. One we're doing inside the summarize, right? And that means, if you'll notice, here we have acr.log, where here we had dat.update $acr.log. So again, because we piped dat.update in, it knows that that's the data that we're engaging with. So if I run this line, what happens? oh, I get this new output that looks very similar to that mean before. This first value has a name called mean.acr.log. Excellent. Oop. I can also, here's a typo that I'm going to have to fix. I can also, rather than just engaging with one summary, I could engage with multiple summaries. So again, here we calculated the mean and the median. We can do the same thing, dat.update, we pipe it into summarize, and now summarize is going to have two inputs. This is the first one. The input is actually this long command with a comma. Here is the second one. Perfect, and then we close it. So this is going to create two new summaries. One is mean.acr.log, the other is median.acr.log, and again, this line of code should look very similar to what we actually have up here. Right, calculating the median of that variable. Awesome, so when we run this, what do we see? We see our output now has two summaries with these two different names that we indicated and with the same values that we had before. Perfect. So this last step, we're going to put a couple more things together. So remember, in previous videos, what have we done? We've taken data, we've manipulated it, and we have assigned that to new objects, right? We've repeatedly manipulated objects and then assigned those to new objects. So that's exactly what we're going to do here. We are taking this exact line, modulo my errors. We are going to take this exact line, and we're going to run the exact same line, only now we are adding this assignment. So rather than seeing this output to the screen, this is now going to be assigned to an object called output.acr. So if we run this and look in the upper right-hand corner of our screen, we see we have a new object called output.acr, and it has two variables. So let's look at the names of output.acr. We see one name is mean.acr.log, and the other name is median.acr.log. Huh, that's cool. Those were the names that we had specified here, or really here, when we created the object and assigned it here. Now, like with any data set, we can specify that we want to engage with these various entries by using the $sign. So again, we can say output.acr $meanacr.log. So maybe let's just look at this one first. Oop. So if we just run this, what do we see? We see we get the value 0.9370704, which is exactly what we saw up here. And we could do the same thing with the median. And if we want, we could programmatically look at the difference. Right? The difference between the mean and the median is 0.1129446. So the mean is a little bit larger than the median in this case. And that generally means that there are a couple of potentially large outlying values. Excellent. So the advantage of doing something like this, rather than just looking at these two numbers and taking the difference by hand, or typing in 0.9370704 minus 0.824158, right, which would give us the same thing, is that here we have a script that is reproducible and will always do the same thing when we run it again. So let's imagine that we save this script. Our collaborator said, oh, I screwed up the data set. Here's the corrected data set. We could take that new data set and run the exact same script, and it would now update and give us the value that is correct for that new data. And we wouldn't have to hand type anything in. Perfect. So this is, I guess, the end of this discussion. This, I think, really summarizes many of the things we engaged with in lab, and I haven't gone through exactly how to do everything we were trying to do on the lab assignment, but I think a number of the things are going to be minor modifications of what I have talked about here. The final thing I want to do, people were asking about this, is so you might want to save your script. And here, this is a script that I had already loaded, and so I can click File, Save, and it ends up overwriting that lab to supplement.script. Let's imagine that let's imagine I had just opened a new script. This is how I'd done this. I was working on a new assignment. I'd opened a new script. I had typed all of this stuff in, right? I'd done all this hard work, typed all of this stuff in. At the top, it said Untitled 1. And I was like, man, I really want to save this so that I can engage with it later, right? What you would do is you would generally click File, Save As, And then you would navigate to whatever folder you want to save it in. In this case, probably I would want to save it in this lab2 folder. I would type in the name, Noah's script, I don't know, or script for lab 2. And I like to, as whenever I can, not have spaces in my names, because spaces can screw things up when you're trying to read in data. So I use underscores instead. You click save. And then if we navigate to that folder, that's where it is, right? Great, script for lab 2 is here, and now I could engage with this in the future if I wanted to. Excellent. Hopefully this is helpful, and see you all later.